given this information again is in the periodic table. Okay. So we know we need 5.5 grams of the sample. And we ask you how many moles it's equivalent to. So the conversion factor is given here. We are converting gram into moles, so we start with 5.5 gram of Fe. Conversion factor, when you set it up, you always multiply conversion factor. You want to cancel all the grams, so 55.847 gram is going to be on the bottom there. That's equivalent to 1 mole. Okay. So if you set it up like this, gram and gram cancels out. We'll give you the number of moles. Okay. And if you do the calculation correctly, that's roughly about 0.098 mole. Next question, how many atoms of iron are in there? And we can continue with this process. Each mole, 6.02 times 10 to the 23. Mole and mole cancels out. So what you do here is that in order to get the final answer, the answer for the second question there is 5.5 divided by 55.847 times 6.02 times 10 to the 23. And you punch the number in the calculator, it's going to be 2 sig fig, 5.9 times 10 to the 22nd. Okay, so that's the number of atoms in 5.5 grams of iron. Now don't try to count those atoms out. It will take you more than a lifetime, as I said. It can take a billion years to count those atoms out. So we're not, in chemistry there, we're not going to ask you to count the atoms out. Rather, if we need certain amount of particles there, we can always weigh them out based on the information given in the periodic table. Any questions about the calculations we've done in these two examples here? What we have talked about here is that given the periodic table, you are given a lot of information about each of the elements. We will be able to use that table as our conversion factor to find our conversion factor, and the rest of it is just plug it in. Make sure you set it up correctly. The units you don't want cancels out, and you end up with the units you do want. Now, how about the calculation involving molecules or compounds? Now we know we've been dealing with different individual elements in there. Okay, so the periodic table gives you the molar mass or atomic mass for each of the atoms there. Now when you have a compound, you must know its formula. Once you know its formula, you can figure out each mole of that compound weighs how many grams. That's our new conversion factor. So in this part of the calculation, there is a little bit more to just going from mass to moles, and moles to the number of molecules. Once you have the number of moles molecule, say H2O, each molecule of water has 2 hydrogen atoms in it. So if you have 1 mole of water molecule, you would have 2 moles of atom, hydrogen atom, 1 mole of oxygen atom in there. So taking into consideration, once you get the number of molecules there, we also need you to be able to determine the number of atoms of each element in the molecule there. So one step further, once you determine the number of particles as the number of molecules in a given amount there, and take a look at the formula of the compound, you can also determine the number of atoms there. We'll give you some examples here. Here's an example. So if you have a solution that contains 10.6 grams of glucose, we ask you this question: how many moles of glucose are present? How many molecules of glucose are present? How many carbon atoms or hydrogen atoms, for that matter, or oxygen atoms are within these glucose molecules? Again, nothing new, dimensional analysis. Okay, we need our conversion factor. And our conversion factor given here is that we don't really have to give you this number. As long as we give you a periodic table, you can figure out this number, because you have 6 carbon, 12 hydrogen, 6 oxygen. If we give you a periodic table there, you add all the things together. 6 times 12, 1 times 12, 6 times 15. You add everything together, you get 180.157. Okay, so we have 10.6 grams of glucose to begin with. The first question asks you, how many moles of glucose are present? Well, each mole is 180.157. So this calculation will give you the answer to the first question. Converting mass into moles, if you know the molar mass of the compound there. Okay, so in this case, if you do the calculation, gram and gram cancels out. That will give you the number of moles of glucose there. The next question asks you how many molecules of the glucose molecules of glucose are present. Well, if you get the number of moles, each mole 6.02, 10 to the 23. Remember, each mole of anything contains the same number. Each dozen of anything contains 12. Each mole of anything contains 6.02 times 10 to the 23. That many number of molecules. Okay? So mole and mole will cancel out. This will give you the molecules. Number of molecules. Now the next question, how many carbon atoms are within these number of molecules? Well, our new conversion factor, which is hidden there, we know for each molecule of glucose, we have 6 carbons in there. So if you have this many molecules, molecules cancels out. The number you got in terms of molecules multiplied by 6 will give you the number of carbon atoms. Now the question is, how many hydrogen atoms do we have? What do we put in here? Wake up, people. 12, thank you. Because each molecule has 12 hydrogen in there. Okay? If you have this many number of molecules there, multiply that by 12. That will give you the number of hydrogen. How many oxygens are in there?
6.
6 times 6. Okay? So that's the calculation. The number of moles there, 0.0588. And that's 10.6 divided by 180. Okay? That will give you 0.0588. And then number of glucose there, this number is 0.0588 times 6.02 times 10 to the 23. That will give you 3.54 times 10 to the 22nd. That's the number of molecules we have there. And then the number of hydrogen atoms, carbon atoms in that case, would be 6 times this number. 6 times this number give you 2.13 times 10 to the 23. That many number of carbon atoms there. Same number of atoms for oxygen, but twice as many numbers of hydrogen. Okay, so this is the type of calculation we need you to be able to do. And given the periodic table, now you have a giant conversion factor, table of conversion factor at your hand, and these are the calculations that we want you to do. Okay, so the relationship between the number of particles in the number of molecules you have versus number of atoms in each of the in all of those molecules there. Use an analogy here, and if you have a car here, if you have 1 mole of car, we can ask you how many moles of tires do you have, assuming you have 4 tires on each car. The number of tires would simply be 4 times the number of moles of car. So if you have a 1 mole of molecule of glucose molecule there, how many moles of carbon do you have? You multiply by 6. Hydrogen you multiply by 12. Oxygen multiply by 6. And going back to a simpler molecule, H2O, if you have 1 mole of H2O molecule, you would have 2 moles of hydrogen, 1 mole of oxygen. So that